Exercise 7. We have the function gx equal to x cubed minus x squared minus 1. Part A 1. Calculate g prime x. G prime x equal derivative of x cubed is 3 times 2, 6x squared minus 2x. Table of variation. To construct table of variation, we have to solve first g prime x equal to 0, 6x squared minus 2x equal to 0. It is equation of a second degree. We can take x common, x into 6x minus 2 equal to 0, x equal to 0, or x equals 1 over 3. Table of variation, we have to put x, g prime x, gx. Domain of definition is minus infinity and plus infinity. We have two roots, 0 and 1 over 3. Since it is a second degree equation, it is 0 at 0 and 1 over 3. Between the roots, which the roots are 0 and 1 over 3, it takes the opposite sign of a. A is 6, so opposite sign of 6 is negative, positive, and positive. Limit, so it is increasing first, decreasing, increasing. At minus infinity, limit as x tends to minus infinity of gx equal limit of the highest degree, which is 2x cubed equal minus infinity. This is why we put here minus infinity, and the limit of gx as x tends to plus infinity. We take the limit of the highest degree, which is 2x cubed once again, which is plus infinity, and this is why we put here plus infinity. The maximum, g of 0 equal minus 1. This is minus 1 here, the maximum. And the g of 1 over 3, it is equal minus 28 over 27. This is a simple part. Calculate g of 1, part 2. G of 1 is 2 minus 1, which is 0. Deduce the sign of gx. To deduce the sign of gx, we can use the table of variations. In this table of variation, we add the number 1. 1 comes after 1 over 3. This is 1. I add 1 to this table. At x equal 1, g is 0. If we notice the sign of g, here it is minus infinity, it is negative. Here it increases to minus 1, it is still negative. It decreases to minus 28 over 27. It is also negative. Then it reaches to 0. So gx less than 0 if x less than 1, and gx greater than 0 if x greater than 1. So for x equal 1, gx equal to 0, and gx positive if x greater than 1, and gx negative if x less than 1. As we said, it is from table of variation, or we can put this small table here x, here gx. Domain is minus infinity plus infinity, and we put the value that make gx equal to 0. The value that makes gx equal to 0 is 1. To know the sign, I take a number which is smaller than 1, like 0. 0 belongs to the interval minus infinity 1, and I replace it in gx. So if we take a number less than 1, for example, if we take x equal to 0, and we replace it, g of 0 equal minus 1, negative. So here it is negative, and the second interval it is positive. So gx negative for x less than 1 and positive for x greater than 1. Part B. We have another function which is named fx, defined by x cubed minus x squared plus 1 over x. Its domain, since we have x in the denominator, minus infinity 0, union 0 plus infinity. It is given. Part 1, we are going to show that the y-axis is an asymptote. The y-axis is of equation x equal to 0. We are going to show it is a vertical asymptote. So the y-axis who will x equal to 0. The x-axis who will y equal to 0. To prove a vertical asymptote, I have to find the limit as x tends to 0 minus. 0 minus, I replace x by 0 in the function. I get 1 over 0 minus. So it is minus infinity. As x tends to 0 plus, I replace x by 0 in the function. I get 1 over 0 plus, which is plus infinity. So we have x approaches 0, y approaches infinity. We say that x equals 0, which is the y-axis, is a vertical asymptote. Now part 2, show that f prime x equals gx over x squared. So we have fx is given, which is x cubed, fx equal x cubed minus x squared minus 1 over x. It is of the form u over v. U equal x cubed minus x squared minus 1. Its derivative 3x squared minus 2x, derivative of 1 is 0. V equal x, so v prime equals 1. We apply the rule of the quotient of the derivative. F prime x equals u prime v minus v prime u over v squared. U prime is 3x squared minus 2x, bv, which is x, minus v prime, which is 1, times x squared, x cubed minus x squared minus 1. We expand 3x squared times x, 3x cubed minus 2x squared minus x cubed plus x squared plus 1 over x squared. So f prime x equal 2x cubed minus x squared minus 1 over x squared. So it is equal gx over x squared. Now it is required to set up the table of variations. So always we have to solve f prime x equal to 0. Here f prime x equal gx over x squared. Since x squared is always positive, then f prime x and gx have the same sign. F prime x equal gx are x squared positive, so f prime x has the same sign as gx. Before one part or two parts, we said that gx positive if x less than 1 and gx is positive if x greater than 1. So in this table of variation, x varies either minus infinity, 0, which is the domain, and we have plus infinity, f prime x, fx. As we have seen in the previous parts, that for gx, this is gx, before 1 it is negative, and greater than 1 is positive. So in this table of variation, I have to add 1, since f prime and gx have the same sign. So before 1 it is negative, and after 1 gx or f prime x is positive, negatively decreasing, then negative decreasing, positive, then it is increasing. To calculate the maximum or the minimum here, f of 1 is equal 1. This is why we put here 1. We have determined the limit at 0 minus, we get minus infinity, and 0 plus is plus infinity. Now, point of inflection, we will discuss it later, but I will give a small explanation here. The point of inflection, by definition, is the point where the second derivative, f double prime equal to 0, and it changes sign. So to find or to determine the point of inflection, we have to determine the second derivative. The second derivative is the derivative of the first derivative. The first derivative, f prime x, is calculated 2x cubed minus x squared minus 1 over x squared. Now once again we have to calculate the derivative of f prime, which is called the second derivative. It is of the form u over v. U is 2x cubed minus x squared minus 1. And the new prime will be 6x squared minus 2x. V equal x squared and v prime is equal 2x. So the second derivative here, f double prime, which is the derivative of f prime, is u prime v minus v prime u over v squared. This is u prime, this is v, this is v prime, this is u over v squared. We expand 6x power 4 minus 2x cubed minus 4x power 4 plus 2x cubed plus 2x. By reducing, we get 2x power 4 plus 2x over x cubed. So we get 2x by factorization into x cubed plus 1. We solve the second derivative equal to 0 to find the point of inflection. G double prime x equal to 0. So 2x into x cubed plus 1 equal to 0. Product equal to 0. 2x equal to 0. It means x equal to 0, which is rejected, doesn't belong to the domain. Domain is minus infinity 0, union 0 plus infinity. And x cubed plus 1 equal to 0. It means x cubed equal minus 1, x equal minus 1. To determine the point of inflection, I put here x. Here I put the second derivative. This one should be f double prime, not g double prime. This one, f double prime. Domain of definition is minus infinity 0 and plus infinity, and I put the value that makes f double prime x equal to 0. The value that makes f double prime x equal to 0 is minus 1. Now, if you notice the second derivative, in the second derivative it is 2x into x cubed plus 1. So between minus 1 and 0 it is negative, and outside it is positive. So here the second derivative changes sign. We say here I minus 1. To find the value of y, I replace minus 1 in the function by calculation f of minus 1, which is 1. Minus 1, 1 is called the point of inflection, is the point of changing the sign in the second derivative. We are going to show fx equal minus 1 has one root alpha, and we need to verify that alpha is in that interval. As we said in the previous exercise, exercise 6, f is continuous and strictly decreasing over minus 0.5, minus 0.54. From the table of variation, minus 0.55 minus 0.54 belongs to the interval minus infinity 0. Over this interval, the function is decreasing. This is why f is continuous and strictly decreasing over minus 0.55 minus 0.54. I find f of minus 0.55. It will be minus 0.96, which is greater than minus 1. F of minus 0.54 equal minus 1.02, which is less than minus 1. So fx equal minus 1 has 1 root alpha, and alpha belongs to this interval. It is a rule to show fx equal k has 1 root. We have to show f is continuous and monotone over the given interval. I find fa should be less than k and fb greater than k. Now it is required to calculate limits at infinity. Limit as x tends to minus infinity, we take limit highest power. على highest power we get limit x squared after simplification. Minus infinity squared is plus infinity. Similarly, limit as x tends to plus infinity of fx equal limit للhighest power على highest power. It will be this one. This should be x squared, not x cubed. It will be plus infinity. So from in this table here, this one should be plus infinity, not minus infinity, and this is plus infinity. Okay, please correct them when you are solving. Now we have to calculate f of minus 3. It is required to calculate f of minus 3 and f of 3. These are given as particular points whenever we are going to draw the curve. Now, the last part, or before the last part, we are going to draw C. To draw C, we have x equals 0. X equals 0 is a vertical. We have x equals 0, which is the y-axis, which is the vertical asymptote. هذا x equal to 0. Vertical asymptote. We don't have any other asymptote. This point is minus 335 over 3. This is the point of inflection, minus 1, 1. This is the point 1, 1, the maximum point. And this is the point, particular point 3, 19 over 3. So to draw the graph, we have to follow the table of variations. Table of variation, first arrow, the curve is minus infinity plus infinity. You have to change this one. And it goes to 0 minus infinity. Minus infinity plus infinity is from that point. Then it goes to 0 minus infinity. This is 0 minus infinity. Second branch from the table of variation, it starts from 0 plus infinity. 0 plus infinity is here, near the vertical asymptote, decreases to the minimum, then goes to plus infinity. We have this particular point. It should pass through this particular point. The last part, we are going to discuss the number of roots of the equation x cubed minus x squared minus mx plus 1 equal to 0 according to the values of m. This is a third degree equation. We cannot solve it by calculation, so we have to solve it geometrically. Always such type of equations, they must be changed into the form m equals fx. So I put x cubed minus x squared plus 1 to one side, mx to the other side, then m equals x cubed plus x squared minus x squared plus 1 over x, so m equals fx. Geometrically or graphically, from last year we have solved such an exercises. The number of roots of this equation are the number of points of intersection between C and the line y equal m, which is parallel to the x-axis. So fx equal m graphically is the intersection between the curve and the line y equal m parallel to the x-axis. Here, this is the line y equal m. We start from below, هذا y equal m، هذا line هون. every line here will cut the curve in this region. From this region to that region will cut the curve in 1 point. So from minus infinity to 1, from minus infinity to 1 here, any line parallel to the x-axis will cut the curve in 1 point. So we have 1 root. If m equal 1, this is m equal 1, it will cut the curve in 2 points. So we have 2 roots. And for m greater than 1, or m belongs to the interval 1 plus infinity, we have 3 roots. So I write them on the graph, and we can write them. If m belongs to minus infinity 1, we have 1 root. If m equal 1, 2 roots. And if m belongs to 1 plus infinity, we have 3 roots. This is all about this exercise.